The AI black box problem, a term describing the opacity of complex AI systems, particularly neural networks, where even the creators can't fully explain how specific decisions are made. We'll also explore the pivotal role of algorithms. Neural networks are the backbone of many AI systems, consisting of layers of interconnected nodes that process data. As these networks grow in complexity, tracing the exact path from input to output becomes exceedingly difficult, rendering the systems a black box. This lack of transparency poses challenges in understanding and trusting AI decisions. Algorithms are a set of rules or instructions that guide the learning process of neural networks. They determine how data is processed, how patterns are recognized, and how decisions are made in context of the black box problem. Advanced algorithms, especially in deep learning, involve numerous parameters and layers, leading to intricate models whose decision-making process are not easily interpretable. The proprietary nature and complexity of these algorithms often results in lack of transparency, making it difficult to understand how specific outcomes are derived. Algorithms can inadvertently learn and perpetuate biases presented in training data, leading to unfair or discriminatory outcomes. Black box AI excel at analyzing vast and unstructured data sets, such as images, text, and voice, uncovering subtle patterns that might elude traditional models. These models often outperform similar algorithms, achieving accuracy levels comparable to or exceeding human experts in tasks like medical diagnostics. Black box AI can make real-time decisions without human intervention, enabling automation across various industries. The complexity of black box models can prevent developers from properly understanding and auditing them, even if they produce accurate results. If trained on biased data, black box models can perpetuate and even amplify the bias, leading to unfair outcomes. The opacity of these models makes them susceptible to adversarial attacks where malicious input can lead to incorrect or harmful decisions. In 2018, Stanford researchers created a neural network model to predict mortality for hospitalized patients, particularly end-of-life care planning. While initial tests of the model showed high accuracy rates, concerns about reliability in real-world patient care quickly arose due to its black box nature. The Apple Card faced allegations of gender bias discrimination due to its biased credit limits against female applicants, a claim that gained traction in 2019 that led to an investigation by the New York Department of Financial Services, while Goldman Sachs, the issuer, stated that gender was not a factor in the algorithms and credit decisions were based on individual income, creditworthiness. The issue sparked a widespread public conversation about bias in algorithm decision making and potential discrimination in lending. In 2018, Recruiters reported that Amazon's automated hiring system, which was developed in 2014, exhibited bias against female applicants. The company ultimately scrapped the project after realizing it unfairly penalized women applying for technical roles. To mitigate these issues, the field of explainable AI focuses on developing methods to make AI decisions more transparent. Techniques like feature visualization, layer-wise relevance propagation, and salience maps aim to shed light on how neural networks process information. While black box AI offers significant advantages in handling complex tasks, its lack of transparency poses a challenge that cannot be ignored. Balancing performance with interpretability is crucial to ensure ethical and trustworthy AI applications. Till next time, tot ziens.